Hi everyone. So we'll be solving this positive spewing problem. So it featured into CodeChef Starters 11. So in this problem, we have been given a circular array, and what is a circular array? Like a circular array is basically that an array in which these first element and last element are adjacent to each other. So basically, we can consider all these elements to be present in a circle. So every element has got some element towards its left and some element towards its right. So this is the this is the thing about the circular array. And in this problem, like we have been given a circular array, and something is happening after every second. So the thing that is happening is that for every positive element, the element which are adjacent to this positive element will get incremented by one. So if there is some positive elements, for example, this is one positive element, then after 1 second, what will happen that it will make this 0 to become 1 and this 0 to become 1. Similarly, this 5 will also make this 0 to become 1, and this will also make the element towards its right. So this is the element towards its right to become 1. So basically, it will like increment 1 towards the elements to its left and towards its right. So after 1 second, the configuration will change. Now there will be 1, 2, 3, 4, 5, 6, 6 elements, like six positive elements. So all these 6 positive elements will like uh, add 1 towards its left element and towards its right neighbor. So this thing will happen after every second. So like in this problem, like this will be the state after the 1 second, and this will be the state after 2 seconds. So the in this problem, like we have to answer that what will be the sum of the elements present in the array after k second. So after k second, like the array will like become something else, like all these elements will change. So whatever elements will be present after k seconds, we need to return the sum of the all these elements. So this is basically the output we have to return. So we can have a look to the constraints. So basically there will be 10 power 4 test cases, and this n will range from 3 to 10 power 5, and this the the elements are ranging from 0 to 10 power 6, and this k is up to 10 power 9. So we have to answer like for 10 to the power, we may have to answer for at most 10 power 9 seconds. So we can easily see that if we'll try to simulate this situation, then it will eventually TLE. So because this n can go up to 10 power 5, so like for all the test cases, the n will be up to 10 power 6, and this k is also 10 power 9. So 10 power 9 into 10 power 6 is a huge number. So we will have to optimize it. So like we can like have a observation that every positive element is increasing the left element and the right element by 1. So every positive element is contributing to the sum of the whole array. This is what happens. This is the thing that is happening. So if there are 3 positive elements, then after 1 second, the sum of the array will increase by 6. So this is the thing that is happening. So if somehow we will like get to know at what's for a part after a particular second, what will be the number of positive elements present in the array, then we can find how much this sum will increase. And since we know the initial sum, if we know the how will this how this sum will increase after every second, we can find the sum of the whole array, right? So we can find we can like find the number of positive elements by doing one thing. So we for a particular element, we can find after how many seconds this element will become positive. So after one element become positive, it will start contributing to the array. So suppose this element I will become positive at t after t equal to t seconds, right? So how much how much it will contribute to the sum of the overall array. So it will basically, so if we have to answer after k seconds, so it will basically contribute k minus t into 2. This is the this will be the contribution of the element to the sum of the array, right? So basically we need to find after how much time a particular element will become positive. So the elements that are already positive are will become positive at t equal to 0 second. So for them t will be 0, t will be equal to 0, and for the elements that are not positive, we have to find. So if we will pay attention, we can know that this element after every second, this 0 will become 1. This one will, after next second, it will make this other the 0 towards its right as 1. So the time after which a particular element will become positive is basically the lowest nearest. It is basically the distance between its nearest, its distance from its nearest neighbor. So there it will have got some neighbor from towards its left and towards its right. So we just need to find the nearest distance. So suppose there is some x, so this is a positive element, and there is some y, right? And there are basically zeros, a lot of zeros between them. So if we want to find the time at which this element will become positive, so we can find its distance from this x and its distance from y, and we can take minimum of these two. So that will be the time after which it will become positive. And after we find this time, we can subtract this t into k and then multiply it with 2 and add it to the sum. So this is how we will get the final sum. Now to find now every element will have an left neighbor or right neighbor if the array is not empty. Like it may be possible that this array is initially all 0, so it will, since there is no element, no positive element in the beginning, so no element will change. So in that case this answer will be 0. So we need to check whether all the elements are 0 or not. So if all the elements are not 0, then we will do implement this, we will run this algorithm. So this algorithm says that we will find the left neighbor and right neighbor and take minimum distance of this element from them, but for that it will take n iterations for finding the t for each element, and we will have to find the t for all the elements. So the time complexity will become order n squared, and this will give us TLA because there may be 10 to the power 6 n over all the test cases. So we need to do it in order n. So how can we do it in order n? So we can understand how to do it by considering this array. So suppose there is an array, and there is this positive x and there is positive y. So, and between them there are only zeros, right? So what will happen after 1 second? This x will make this 0 as 1. After 2 seconds, this 0 will also become 1. After 3 seconds, this 0 will also become 1, and this after 4 seconds, this 0 will also become 1. Similarly, after 5 and 6, these 0 will become 1. If you will consider it from the point of y, after 1 second, it will make this 0 1. This after 2 seconds, it will make this 0 1. Similarly, after 4 5 6, this 0 will become positive. So a particular 0 will become positive if we will take minimum of these two quantities. So it for the zeros present nearer than y, they will become positive in 2 seconds, not in 5 seconds. So if we will if we will take the minimum of such quantities, so some number, such numbers, then we can find the t for all these elements. So this is what we have to do. So what we will do, we will consider this array, and for every for every positive element, we will suppose there is positive element y and there is positive element x and there is positive element z. So what will we do? We will, if we will encounter a positive element, then we will have a, basically we will use two arrays, right? So we will, like, suppose this is the original array, and there are some positive elements in it. So this is one positive element, there is one positive element here, and there is one positive element here. So and we will use one array, and I can call it we can call it right, and we can have another element, another array, we can call it left. So if we'll encounter a positive element, suppose this is, now we have got 10 elements. So if we'll encounter any positive element, then we will, like, we will keep a variable current, and if we'll encounter a positive element, we will set this current to 0, and we will increment this current after every step. So this current is 0 at this place. So if this current moves here, this, it will become 1. So we will write 1 here, then we will write 2 here, then it will become again 0, and now, like, it will again become 1 here. Then since it is a, there we, it has encountered a positive quantity, it will again become 0, then it will become 1. And since it is a circular array, we will move past it to start from here. So if there were some elements here in the start, then we will write 2 3 up to the element with which we started, and similarly we will write 1 2 3 and 4 in this way, in the opposite direction. So we will start from from this direction. So this current will become 0, will remain 0 at this position. So after it move towards left, it will become 1. Since it has encountered y, it will again become 0. It will be, after moving from y, it will become 1, then it will become 2. Then now it has encountered x, so it will become 0. Now it will go past the array, and it, after x it was 0, so after that it will become 1. So this is how we will be writing this, and after writing this, we will take minimum of these quantities. So whatever will be the minimum of these quantities, that will be the time for that element to become positive. So I hope you guys may have understood this algorithm. So instead of taking two arrays left and right, I will take one array time, and first I will do what I will, like, initialize this like array with the all the quantities that we have got after in this right array, and then after I will be doing processes for this left part, I will, like, take minimum of the current with the element already present in that array. So by doing this, we will get the current, like, a time of every element. So this is the approach we'll be using to solve this problem. So I can show you the implementation. Like, I submitted this solution at the time of contest, and it got accepted. So what I have done, I have, like, declared a vector array for storing the numbers, and I have declared a vector called time. So it will store the time at which a particular element will become positive, and I have taken this n and k as input. I have resized this array ARR and time to contain n elements. I have taken the input here. I am resetting this time to 0. So I will, like, I will be first finding the leftmost element that is positive. So if this is the element, this is the array, so we will be finding the first element that is the leftmost positive element, and we will also be finding the rightmost positive element. So the reason why we are finding, because we want to start this process of writing 0 1 2 3 4 from that element, and similarly for the process when we'll be doing this in the left direction, so we want to start it from the right element, and we will continue this process until we reach back to the point from at which we started. So that's why I have declared this left variable. So I am like iterating over this array. So whenever like I got a positive element, I have set this to left equal to I, and I have broken out of this loop. Similarly, I have done it for the right variable. So here also like I am iterating from n minus 1 to 0, and if I am encountering a positive element, I have setting this right equal to I, and I am breaking out of this loop. So if it may be possible that there are no positive elements, so in that case both of these variables will be equal to -1. So I have checked for left. So if this left is -1, I am outputting 0 as an answer, because if there are no positive elements in the start, this array will always remain 0 sum array. It like there will be always 0 elements equal to 0 in this array. So that's why I am like outputting the answer as 0, and I am using continue to solve the next test case. So just in case we are encountering a positive element, then I will I have set this current equal to 1. So I am planning to start from just after this leftmost positive element. So that's why I have started with current equal to 1. So for starting to the element towards the right, I am using left plus 1 and mod n, because it may be possible that this leftmost element will be the last element. So in that case, if we will not be doing a mod n, then we will get array index out of bounds, right? We'll get runtime error. So after every step, I am doing mod with n. I am checking whether I have arrived to the element with which I started or not, and I am updating I equal to I plus 1 mod n to move towards the right. And at every step, I'm checking whether we are encountering a positive element or not. So just in case we are encountering positive element, we are setting this current equal to 0. And if we are not encountering positive element, then I am setting this time I equal to current. And I am making sure I am incrementing this current after every step. And now this is the process when we are moving in this direction. So now after we have updated this time array with the numbers, when we are moving in this direction, now we have to do the similar thing in this direction, and we have to take the minimum of the numbers encountered in this while moving towards this direction with the elements with the numbers already present in the time array. So similarly, I am initializing this current equal to 1, and I am starting from the left element from the rightmost positive element. So I'm starting from here, and after every step I am doing I equals to I minus 1 plus n mod. The reason why I am doing plus n, because in C++ what happens that if you will take mod of like a negative element, then it will result into a, like suppose this will be 0, but if you'll take a -5 mod 2, it will give you -1. So this is not what we want. We want the answer to be from 0 to n minus 1. So that's why I'm adding plus n and then taking mod. So I'm doing the similar thing. So if there is a positive element, I'm setting this current equal to 0. And if it is not a positive element, then I am just taking the minimum of current with the element already present in this array. So after doing this, we have got the time. Now we can find the overall sum of the array after k seconds. So I am like adding the already present element to the sum, and I'm also like adding the contribution of that element to the total sum by doing k minus time of that element at which it first appears into 2. So this was what we have discussed, and it may be possible that this k minus time I will be negative. So to avoid that situation, I have used this max 0 comma that element. So just in case this will be positive, so just in case this will be negative, so if I had said that this element will maybe positive, I mean that this element may be negative. So just in case this element may be negative, this whole quantity will become 0. So it will not, it won't cause us harm. So after doing this I am outputting this sum. So this was the solution that I submitted during the contest. So we can try it on the sample test cases. We can get rid of this. So this was a sample test case, and we can see that the output is 632366, and this sample output is 632366. So if summation is still allowed, we can submit it, but like we cannot submit it because the contest has just finished. I can try to refresh this page. Yeah, we can submit it. So we can try submitting it. So this file is basically c.cpp. We can see that we have got AC. So thank you guys.